That does sound familiar. Is that freaky one? And you're like, saying that freaky one is not enough description to distinguish it. Yeah, that is the freaky one, okay. Almost always, I mean 99.99999% of the time, you're never going to do guess and check. This is one situation where you basically have to, but the guess is pretty obvious. So the main thing of this problem is to make sure you understand inverse notation. What it was? Yeah. So one of the simplest mistakes is just put a 2 in there. And that's not what it's asking, right? It wants you to figure out what f inverse of 2 is. So where would the 2 actually go then? Yeah, it would go in place of y, right? F inverse takes x as an input, gives you y as an output, or the other way. F inverse takes y as an output. So you replace this with 2, and then I had a lot of people like, is there a way to solve that besides just guessing? No. I had somebody do some really interesting stuff, and I was really excited for a second. I was like, oh, you figured out a way? No, you just kind of put the answer at the end, and nothing really matched. So I'm like, all right, whatever. But this one, you really just have to do it on site. If it was just this, of course, the answer would be 1. And what's natural log of 1? What's natural log of 1? 0. So it really, at 1, it really is just that. So I basically just did it for you, but just verify. I'm not going to say it again. I just did the problem for you. So if you didn't catch that's too bad. Cool. So that one's a little weird. That's going to be, it's never going to happen again, basically. But this is just really more, do you understand what this notation means? You want the output to be 2. And then you have to do it on site. You could do this graphically, but basically assume I want you to do something by hand unless I say in the description, oh yeah, do this graphically. Right? I moved recently. I can't find my shirt that says show your work. I wanted to wear that today because a lot of the homework I looked at, answers are just popping up, you know, like wildflowers after rain. There's just answers, poop. And I need to see where the hell it's coming from. That's the part I need to look at. I almost don't give a shit about the answer. So you must show your work. Unless the problem says, graph it and just look at it and tell them, you know, it's the one time you don't have to show me something. You guys with me? It's going to be a mantra. I have a shirt that says it. I'm going to say it on every test. Show your damn work. Yes?
Didn't you find that inverse?
Can you find the inverse?
No. Well, don't you have to find the inverse of the function?
Nope. You sure don't? Mm-mm. I know that this means I want the output to this to be 2. And then you can do this on site. Now, I totally, trust me, I love that it's hardwired into you, that you shouldn't guess and check or something like that. It's beautiful. Never, 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 except for this problem. I don't know why. It's a weird little problem. I'm not sure if I like it or not, but oh well. It's really just, do you understand what this means? And do you understand that you cannot find the inverse? If you can, please show me. Yes?
Well, wouldn't that be f of x equals 2, not f?
Totally. So the input for a function is x. So the output of an inverse function is x, right? Are you guys with me? And then I could do f. So it really is asking 2 is equal to f of x, and that's why I put a 2 there. So this really says I want the output to be 2 because it's the inverse. It switches output and input. That's really what this problem is about, is do you understand how the inverse works? Maybe. There was another problem where you actually had to find the inverse, and it was for like the ratio, which always trips people up. If you've done the homework, you know what I'm talking about. Anything else, some homework stuff? All right. I'm going to be optimistic and assume that means homework is happening, but it's just going really well. All right. Just to remind you, if you get homework back from me, correct, and I've looked at it and I say correct, or finish, or redo, you have until the day of the final to turn that in. Just turn it in whenever you can. Yeah? 24? Oh, that's the one. There you go. Ooh. So this one says, given, yeah. Remembers the steps to find the inverse algebraic. I mean, graphically, what do? You take all the points and you switch the x's and y's. So algebraically,
so you have to make x over 1 and you cross multiply, right?
all right, no, wait. So before you get into the details, tell me what you are doing to get to where you're talking about. Replace f of x with what it really is. Y. Then, I always draw a little dotted line. Stay with me now. This is just me. Because what I'm about to do is nothing algebraic. I'm applying a concept. Somebody help me out. I want to switch the x and y. What's the inverses? What do you always do? Switch the x and y. Always. It's insane. How you guys do? So then I switch the x and y. Put this over 1 if you want to just multiply that shit up there, right? Then the trick is, what are you trying to do now? What's the next thing you're trying to do? Resolve for y. Why does it make sense that it finds the inverse? Because in the process of solving for y, I'm going to do all the opposite shit in the opposite order. So of course I'm going to end up with the inverse. That's why this process makes sense. But when you do this, when you multiply that up, you got 2 y's. You really don't. Get all your y's on one side and factor a y out, you got 1 y. Okay, and then divide by the shit you don't want. So how do you solve an equation for a variable when there's more than one of that variable? Put them all on one side, factor it out, divide by the shit you want. Does that sound familiar? Yes. I don't want to do this until more of you have done it. I have a feeling that not enough of you have tried this yet. So I'm going to do it for you. I've already done some of your homework for you. Yeah.
Can you do 6 real quick?
Oh yeah. Okay. This is the neat one. I love this one. It's where work sort of starts and then magic happens and the answer shows up. This is the one that's square root of 16 minus x to the 4th. So they want the domain and the range, right? And range. Damn. Alright, so what's domain mean? All the values of x you're allowed to use. They make it come out not complex. If they want me to use complex answers, they'd have to specifically say the domain across complex numbers. They didn't, so I don't want complex numbers. Right? So I mean, is it obvious that can you guys? So this is where you need to start stepping outside of just rote steps and stop and think about what the problem is. Can x be 3?
No.
No, because then you get 16 minus big is negative. So what's the biggest positive number x can be? 2, because that makes the inside 0. Anything beyond that makes the inside negative. The 0 word. Yeah. So does negative 1, of course, because then it would just become positive. So, of course, it works from 2 down to negative 2. You can kind of just see that. I do need some work, though. So you can either explain to me. Explanations are very often work. I like to say that the more you understand, the less you should have to do. But you still got to explain to me where the shit's coming from. Don't just put negative 2 to 2. Yay. I don't know where they came from. And this problem doesn't say graph it and get the answer. Right, little black box doing all the work for you. Screw that. So you could do this kind of work. What's got to be true about the inside of a radical to remain real? I love it. And then people freak out a little bit about how to actually do this. Right? But if I take a fourth root, I basically get it's not always that cut and dry, but this one's pretty straightforward. And then you just have to know how the hell to deal with this. When I teach absolute value inequalities, when I first teach that, this would be going into a haunted house. Stay close to me. I want the distance to be less than something. Greater than would be restraining order. Stay the hell away from me. Right? So this one, stay close to me. It should look like this then. The answer should be like this. Stay close to me. I want the distance, absolute value, to be at most 2. The distance from 0 to be at most 2, so of course that would be negative 2 to 2. Right? You can rewrite this as negative 2, blah, 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 blah. So you can either just kind of explain to me why it makes sense, just on observation, or you can do that kind of work. Don't just get to here and then suddenly have the answer. How the hell do they connect? I don't know, you didn't show me. And then the range is interesting. If I can make this the smallest, the output's going to be the biggest it could be. Does that make sense? Because I'm 16 minus this. So if I make this as small as it could be, the output is going to be the biggest it could be. And vice versa. Right? So show me some work. Don't just have it show up out of nowhere. Just tell me the idea and then put the answer. Does everybody kind of get what I'm saying? How the range works for this? Yes?
If we're doing the domain, we're doing brackets. Are we going to do open bracket or closed bracket? Like
The answer's right there.
so
It's allowed to equal to, so, and negative 2. So it's going to be bracket. So I always, this looks like the letter I for include, right? And this looks like half of an open circle, which we used to use for exclude. I mean, if you have any trouble with interval notation, that's a way to remember. Okay, how are we doing so far? Okay, cool. I like it. Anything else from homework stuff? Yeah.
19.
You see, how many more do I do till I done Algebraic? Oh, okay. This is another one where sometimes there's not enough work shown. 19. 19's that one where we have to do a composition of functions. So you have to remember what the hell this means. I always love this. It's like how students feel. Fine. This notation is stupid. You're like, I never heard a teacher say it, but there's a lot of notation that I wish I could invent a time machine and go back in time and say, what the shit are you people doing? This is stupid, right? What does this really mean? What's wrong with this? Nothing. Nothing. But oh well. Just remember that's O like of. Like o'clock. Right? F of G. F of G, there you go, sweet. So really for F of G, just plug G into F, and then they ask you on top of that, the thing you just created, tell me what the domain is. And I need to see some work for that. What's the domain of natural log of X? This might be a very boring class. I'm just going to stand here. What's this thing look like? You graph it. Yeah, it looks like that. Where's this thing? What's this thing doing? Where's the asymptote? Yes, the y-axis. So x equal to x equal to x equal to, what is that x equal to? 0. The y-axis definition is x equals 0. That's why you make x 0 to find the y-intercept. Okay, I like it. So there, if you know what it looks like and you know where this is, you know the freaking domain. What's the domain? What x's am I allowed to use?
All numbers greater than 0.
Yeah, greater, okay, I like it. X greater than 0, a little bit better is 0 to infinity. Why do I never put a bracket here real quick? Yeah, if you do that, I'm like, show me. Get to infinity and then come bring it to me, right? Yeah.
Well, for part A of 19, it's you get ln x squared minus 9.
Yes, I love it.
So with the x squared, I didn't know how to find
So it's sort of related to that one over there. And so when you do part A, so here's the idea in general for natural log of any damn thing. It's that damn thing greater than 0. So if you got natural log of x squared minus 9, what's got to be the domain? Well, the inside has to be greater than 0. Here's a really good example of a quick way to do this. It would have worked over there too. What would this look like if you graphed it? Because you're not going to graph it. Well, what would it look like if you did? Parabola. Be more specific.
Parabola 9 spaces down.
Opening up. I like it. So this is asking where is it positive? Without using graphing calculator, you know it's going to look like that. 9 spaces down. So where is it positive is below this and above this. Well, what are these? And what are they? 3 and negative 3. I like it. So it's outside. So it's going to be negative infinity to negative 3 and then 3 to infinity. I mean, that's a beautiful example of solving a problem, not using your graphing calculator, but your understanding of what things look like. What is this asking? When is this a parabola greater than 0? When is it positive? Well, outside of its intercepts. And what are we going to use, brackets or parentheses? I like 50-50. It's not allowed to equal 0, so you're going to use parentheses on those 3's. Or you can add 9, square root, absolute value, like we did over there. The only problem is you're going to get this, and that's the restraining order. You must be at least 3 feet away from me. So you can still throw shit at me, but you can't come closer. 3 feet. Screw you. So this would be x greater than 3 or x less than negative 3, blah, blah, blah. Is that all kind of coming back a little bit? If this is like too fast or it really doesn't sync with anything in your head, you got to come see me, right? This is material you need to kind of know already, have seen. It should be coming back. If it's not fully there, that's all right. If you're like, yeah, that sounds familiar, that's not a bad place to be. If you're like, I don't have a clue what this shit's going on, you better come see me, right? Okay. So I'm not saying chapter 1 homework is easy. I'm saying it is stuff you should be able to get through on your own with what you come in with. Maybe a little review. You should be able to get through it. Anything else? All right, let's do this. Let's get back into chapter 2. Towards the end of class, we're going to take a real quick field trip. I hate to call it a field trip. It sounds exciting, but no zoo or museum. Sorry. We're just going to go see where the tutoring centers are, point out where my office is, and then we'll head out after that. Okay. Let's get back into chapter 2. So the whole first part of calculus, there are really only two main concepts we learn in calculus. How to find the slope of any curve and how to find the function given its slope. All right, so it's like one is officially called the derivative. I think I used that word the last time. That's related to finding the slope. So the derivative of a line will always be a number. But anything else is going to have to be a function because it's changing all the damn time. The second part of the class is going to be antiderivative. You know math goes both ways. Don't judge. If I can do something one way, I have to be able to undo it. Right? Inverse idea. So we have derivatives and antiderivatives. I like it. To figure out derivatives, which is finding the slope of things that aren't straight, we start with the idea of limit. That's what's going to let us do this. Somebody remember why. If I have a curve, I want to find the slope at a point. What's inherently wrong with that again? What do you need to find a slope? 2 freaking points. All right, so section 2.1, just a real quick little review. They'll give us a curve, they'll give us some function. Yeehaw. And let's say find the slope here. So section 2 is kind of nice. They kind of give you the stepping in, right? How do we do this? I take something that's a little bit away from A. Right, let's make this -2 just to have something. So maybe I'll do -3, and I'll find this slope. Is that going to be the right answer? What kind of line is this again? Somebody remember the name of this line? Secant line. I love it. And what is it I'm trying to get a feel for? The slope of the tangent line. The line that touches once, that goes through that point, is the tangent line. I'm going to create a series of secant lines to see if I can approximate what it looks like the tangent line slope is going to be. I look for the pattern. So let's do one specific problem. Blah, blah, blah. That looks gross. Let's do that. Sound right? Oh, there it is. That doesn't make sense. So if x is a half, change it to 0.5. I thought it was 5. I'm like, that doesn't work. What's cosine of 5 pi? What's cosine of 5 pi? It's not even, so it can't be 1. And it must be -1, right? Odd pi is, so let me do it from your perspective. I don't know if I can. There it is. So pi would be -1. 2 pi would be +1. All the odd pi's are -1 for cosine, right? All right, I like it. So it couldn't have been 5 because the output would have been -1. What's cosine of 1/2 pi? Cosine of pi over 2? I bet you it is 0. Yeah, right, because that's where sine loves it. This is where cosine hates it. Cosine likes x. Ain't no x on the y-axis. Right? Thank God I don't teach English. Okay, so I'm trying to figure out. So this problem would be find the tangent line slope at that point. So in order to do that, I create a sequence of secant line slopes, because I can actually use algebra to figure those slopes out. And then I try to see a pattern. So they give me in this problem, they say, where are you at? Blah, 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 blah. So x cosine pi over x and 0.5, you want to make that 5. 0, that's going to be my 2 points for my secant line. So if x is 0, what's my slope of the secant line? So this will be 0, comma, let's do this. Let's make it a little easier on you. What's the point, and what's the slope? So this would be 0, 1. Now what's the slope between that point and that point? So it'll be 1 over 1 minus 0 is 1. 0 minus 0.5. -2. I like it. 1 divided by half is 2. Plot the -1. Right? And then in the problem, they're going to give you the next. So what am I going to do with these x's? I'm going to slowly let them get close to 0.5. I'm going to let them march closer and closer into the point that I'm curious about. If I try to put exactly 0.5 in, what would my slope come out to be? What's the slope between 0.50 and 0.50? It's not even 0. It's 0 over 0, which sucks. It's worse than undefined. That is like immovable object, unstoppable force shit, right? What's 0 divided by anything? 0. What's anything divided by 0? Infinite. So what's 0 divided by 0? Shit. It's both 0 and infinity. Yay. What the hell? We'll see later that it actually depends on how quickly the top and bottom are going to whatever. We'll see that later. So we can determine something sometimes, even if it's in it. Right now we can't do shit. We're like, oh god. So that's why we have to use points that are close to that point to get an approximate slope. Are you? This isn't horrible. It really isn't. If they let x go to just 0.4, can you guys fill in the next piece? Fill in the next piece of that table. Or if you don't want to, at least like draw a duck or something, make it look like. Don't just sit there staring at me. So you can approximate that. Or be honest, the best thing you could do. Right, that would be the output, cosine of 0.4 pi. Is that cool? So don't approximate until you're done with the problem. If you round too early, you throw your answer off. 1 degree off in a boat. 8 hours later, who knows where. I don't boat much, but I'm sure you guys get the idea. 1 degree off didn't sound like much. 8 hours later, you are way the hell away from where you're supposed to be. So don't round too early. What would the slope be between these two? It would be cosine of 0.4 pi. Right, bam, minus this. Over 0.4 minus 0.5 is negative 0.1. Now, throw that in your calculator. Now you can round. The problem says correct to 6 decimal places. What the hell is that? Oh yeah, I've lived this experience. Make sure that you're in the correct mode. Radians versus degrees. It will almost always be radians, because radians are true physical measure. Degrees are something we made up, totally. It's like 360 is a nice number. It just came out of nowhere. Actually, it's based on Babylonians' number system. They have a base 60 number system. They did. All right, so let's see, cosine 0.4 pi. What do you guys get? What are you guys getting?
0.323606.
Yeah, I get negative 3.0901699. Good Lord, so. Cool. Now, let me see. Let me leave some room here. All right. So there's the idea. We're slowly stepping in towards the point I want to know the slope at. I can't use one point to get a freaking slope. So what do? I slowly come towards it. From which direction? Both. Both directions I want to come from, right? So on the other side, let's do 0.6 right here. So 0.6 cosine 0.6 pi. Then the slope is going to be cosine of 0.6 pi divided by, in this case, it's going to be 0.1. Please let me know if you currently have no idea where this is coming from. If you don't, there's at least 12 other people that don't. All I'm doing is slope between these points and that point. y2 minus y1 over x2 minus x1. Not a big deal. So what the hell is this? Got it. Kind of expected, maybe. What do you guys get? Anybody do that yet?
Same answer.
Same answer, but positive. Is it positive? No. Same answer, but positive, yeah. 3.0901699. No, it should be negative. Yeah, this thing. Certainly. Otherwise, it would really be freaky. Is everybody cool with that? Why is the bottom positive 0.1 now? Because what's 0.6 minus 0.5? Positive 0.1. Why was this negative? Because 0.4 minus 0.5. Negative 0.1. Okay, I like it. Otherwise, it really wouldn't look like it's approaching anything. And this is a nice function. It should be approaching something. Yes? Yes, if I give you a problem and say, find it yourself, and I want 0.5, what are you going to do? 0, 0.4, 0.49, maybe 0.499. Do you see what I'm getting really close to 0.5? I'm not going straight to 0.499 because then I have nothing to get a pattern from. This problem gave me this shit, right? They're going to be really nice in section 2.1 and say, here's some stuff. Do you guys see where we came up with these numbers? Okay. I'm getting close to 0.5 in both directions.
So for the initial problem, the y equals cosine pi x, that's the equation for the 0.5.
Yeah, this point is on that graph,
Okay.
right? So here's, what would cosine of pi x look like? What would its period be? 2, right? It's k is pi, the period is 2 pi over k. So the period would be 2. Yes?
I have a question.
Yes?
How do you get the negative 0.1?
Okay, so how do I get this? y2 minus y1 over x2 minus x1. I really want you guys, this is the point I'm curious about. These are the points that are stepping closer and closer to that point. I find the slope between each of them so I can get a feel for what the slope is right there. That's the whole idea. That's this. That's the detail of this. Get really close to that point. So all you are doing here is math 90 stuff, right? It's just find the slope. Throw on the calculator, find the slope. y2 minus y1 over x2 minus x1. That never changes. That definition never changes. So what do I want to do? Where was I? Oh. So my cosine of pi x is going to look like this, right? Yeah. So I'm curious about the slope right here. That slope. What is it that we've done so far that makes sense? That slope should be positive or negative. And what have we got so far? Oh, thank God. Right? At least we know it should be negative. It should be kind of big negative too. That's kind of like, looks like the place where it's going down the most. Because what's it doing immediately after this is turning around again. So this is where the slope is biggest negative. Later in this class, we'll actually give that point a name. Not Fred or something. Yeah.
So yesterday when we were going on either side, it would be like 1.9399.
Good, good, good. All right, so what do you think is the next one going this way? What's a good next point here? 0.4, 0.49. And I'll bet you anything 0.51 would be the same thing. We already see that symmetry. It's because the graph is so, cosine is so nice. So if I do 0.49 here, this actually work for 0.51 also. So here, this would be 0.49 cosine of 0.49 pi. Same way as before. That minus 0 is it. That minus 0.5 is negative 0.01. If you throw that in your calculator, you should get a number that looks very familiar. Whatever kind of calculator you have. Get out of there. Yeah, what does that look like it's trying to be? I mean, what do you get? Negative 3.141, 0.75. I'm just taking that out a lot because the problem said correct is 6 decimal places. But what is a really good guess as to what it looks like that's going towards? Pi. which kind of makes some good sense because pi is in there. Pi is in there. But how do you make even more sure about it? You do 0.499. The only thing you cannot use here is 0.5 because that's where things freak this shit out. So what am I going to do? Get really close. I can't touch it because then the blob jumps on my hand and the whole movie happens. Don't touch the damn thing, but get really, oh, you're weird looking, and then walk away. And see what the pattern is. Please don't make more of this than it is. It really is just, oh, I want 0.5. I can't use 0.5. Let me use stuff that gets closer and closer to it. And then I can kind of see what the pattern is. As I go from both sides, it looks like it's approaching negative pi. Interesting. Later in the class, we'll be able to do this problem 2 steps. But we got a lot to learn before that.
So that 0.5 on the 0, that doesn't have anything to do with that first graph.
See, that is a point. That's this point on this graph.
Yeah, but not that graph. On the graph, right?
No, this one was just a general idea. Yeah, I'm sorry. This is just a general idea. I drew this before we even did this problem. Yeah, thank you. So this is the idea. If I'm curious about a point's slope, I have to get closer and closer to that point. That's exactly what we're doing here. I love it. I love it. Yes?
So we're basically supposed to just find points that get closer and closer together and then just throw out a wild guess at one point.
It's not a wild guess. It's an educated, it's an informed guess. I can see the pattern. Here, if you didn't see that, if you don't feel comfortable saying negative pi, you can say negative 3.14108. You probably want to, I think the book, it makes you do, it makes you do 0.499 to be even a little more precise. But if you notice it looks like it's going towards negative pi, that's a good conjecture. We really are making a guess, but not like out of nowhere. What's the slope here? 12? No, we got a little bit more informed guess, right? I like it. The evidence here is overwhelming. That word nowadays is a little bit interesting. But anyway. So that's really 2-1. Please don't make more of it than it is. They give you the x's to use. They're starting off nice. Okay. So now I want to get into 2-2. And I have a little handout that I'm going to have you guys work on here in a little bit that goes over the stuff in Chapter 2 we will have covered. So what do you think, real quick, if you did this whole thing again and you put a 4 here, what would be your guess for the slope at 0.50? 4. Yeah, so, negative 4 really, right? So if you did it and you did it again, you can kind of get a general rule for cosine of AX. The slope at 0.50 would be negative A. It's great.
Is it opposite when it intersects in the x-axis or like cosine?
Oh, I see. It probably has the same slope over here, just positive, right?
Yeah.
Yeah, because again, the cosine curve is so nice that I can make generalizations once I found one thing. That's why we do 1 quadrant's worth of values for it, and then we know everything, right? So I love it. Here's negative pi. I'll bet you over here it's going to be positive pi, and then negative pi, and positive pi. Because it's always got the same trajectory. I love it. Normally a function's not going to do that. Periodic functions, they're awesome. Believe it or not. Okay. So, I really want to make a distinction. 2-1 is using the idea of limit, but it's letting x values get close and then finding the slope on top of that. You with me? So that slope piece has nothing to do with the limit. And the problem we just did, we were curious about 0.50, and I was letting x go to 0.5. But then I wanted to see what's the limit, what's the slope doing as I let that happen. Okay, I like it. So now in 2-2, we're going to take a step back and we're going to just look at limits by themselves. How do limits work, period. So let me draw you guys a picture. Okay, so for this function, f of x, this is, I like to start off like this just to show you, because we're going to do some freaky shit in a minute, but I want you to see that limits don't really care if there's freaky things happening. Is there anything freaky about this function? You might be freaked out that it starts, but I mean, that's normal. You can have a restricted domain, no big deal, right? There's absolutely nothing freaky about this function. What's the limit as x goes to 1? Now what this means is, what does f of x represent? For this function, it is the y, the outputs. So what this is saying is, as I let the inputs go towards 1, as the inputs approach 1, from which side? Both sides. What do the outputs do? So here's 1. So here, where's the output? There. Here, where's the output? There. Here, where's the output? There. What are the outputs going towards? 3. And what is it? Are they doing anything different below? Here, there's the output. Here, there's the output. Here, there's the output. As I let the inputs go towards 1, what are the outputs doing? They are going towards 3 in both directions. So they agree. So what is the limit? 3. How we doing? All right, I like it. So what is the limit? Don't say anything out loud. Think about it for a second. What's the limit as x goes to 3? It is 0. What's the slightly freaky thing about 3? Can I do it from both sides? For endpoints, to be fair, we just say you only have to go from the side you exist on. So to be honest, the way we would show that, put a little negative right there. Do you see what that negative means? It means go to 3 from below. So as I go to 3 from below, what are the outputs doing? They are approaching 0. All right, now how does everybody feel about that? The biggest problem students have with limit questions when I give you a graph is your eyes don't know where the flip to go. Yes?
From below, what do you mean from below?
So limits deal with letting the input approach something. So see how I have, all right, I'm with you, I'm with you. Yes, the x-axis. So I got to be careful. That's the way I was taught, that's the way I've said it, but now I understand students think from below is like, Jaws coming up from below. So from the left. Is that cool? Yeah, from the left. I like it. I got to remember to say it. Yes?
So if you wrote a positive next to it, would it be from the right?
Yeah, and for this problem, there is no limit, because it doesn't exist above 3. But I could say, what's the limit as x goes to -3? Is that right? Yeah. From the right. I'm going to still say from above, so you just got to... What is that limit? Yeah, the outputs are approaching -2 as the inputs approach -3. So you have to kind of do this. As I approach -3, what are my outputs doing? They are approaching -2. Bam. And it is all about training your eyes to look at things correctly. Students are always like, am I looking? No, so here, this limit would be, where'd it go? -2. Okay, now let me contrast that with a slightly different graph. To say it, well, sure, okay. I'll draw it again. Here's example 1. Here's example 2. You do. That would be just one real difference here. By the way, here, what's f of 1? 3. You guys cool with that? When they give you a graph, there's all the answers. Students very often, the first time they see this, they're freaking out. They're like, you didn't give me f. I don't know what the hell f is. And I'm like, you don't want to know what f is. Somebody did all the answers for you. Shit. F of 1 is 3 because that's where they put the point and it kicks ass. No work to do. Yeah. Now, so what if it looked like this instead? All right, it's going to be the same thing, but it's going to be a couple problems. Oh, is that where it was? Yes. Cool. All right, Jeff, you're doing good so far, buddy. I like to encourage myself. That was shit, but that's all right. We'll be all right. So it's the same function, except what's different? There's holes. There's these, what I call these are like giant sinkholes. I used to live in Florida. We had hurricanes and sinkholes. Here we have earthquakes and fire, so it's and this, by the way, is closer, but doesn't really matter, but it's all right. So now watch. What I really, the point I'm going to try to make here is limits never get to the point they're approaching. What's the limit as x approaches 1? It never gets to 1. Because what's the process we just did? Can we ever let x equal 0.5 on that one we just did? No! We get really freaking close to it. That's what limits do. That's why they allow us to investigate weird places, because you never get there. Yeah? It's a weird looking house. I ain't going in there. Shit. So that'll be the limit. And then the other person go in and die and shit. So I'd rather do the limit thing. So here, let me ask you this. What is the limit as x goes to 1 of f of x? 3. It's the same answer. It does not matter if that's filled in or not, because I don't care what is happening right at 1. I don't give a shit. The limit doesn't care. The limit doesn't give a shit what's happening right there. It says, what does it look like? So if I let my inputs get really close to 1, what are my outputs doing? They're getting really close to 3. On this side, they're getting really close to 3. So that limit is 3. You guys see that? Yes?
Why is it 3 if it doesn't reach?
Because the limit never gets to the point it's investigating. So what does this limit mean? As I get really close to 1, what are my outputs approaching? They're approaching 3. This never asks what happens at 1. Why did we build this to mean that? Because then I can investigate weird places. I don't have to actually go there. If you go there, you die. Okay, I'm not going to go there, but I might push me. Oh, shit. Right? You guys with me so far? I like this example because this really just gets to the idea of limit and how to look at it, and then I want you to realize it doesn't matter what's happening there. What is f of 1? What is f of 1? Does not exist, or slightly better is undefined. It's not defined. There's an open circle there. It doesn't go anywhere. So undefined, or something that captures that idea. But say undefined. What's the limit as x goes to 0? 0. Right? Now I love when somebody just said, be careful. The limit does not give the first shit what is happening at that input. It doesn't care. All it cares about, what is it going towards? It looks like it's going towards 0. But what is f of 0? 2. How do you answer f of question? You look where the point is. Well, where's the point for an input of 0? At 2. So the function looks like it's going somewhere, and then it's like, no. The limit is all about what does it look like it's going towards. The function value is where does it actually get? Yes?
Quick question about when it goes towards 3. Since it ends, if it just says to the limit of 3,
Oh, okay.
just mention 1 side?
So automatically, if you're dealing with an endpoint, even if I would have just said this, it's assumed that it means from below.
Oh, okay.
Because you would assume that's what's meant, because it doesn't exist on the other side. So endpoints get a few caveats. We have to be fair to them. Because they're like, I know I'm an endpoint, but it's not my fault. Just can't use shit over this way. So we want to be a little fair. And it's going to show up every now and again through the semester where we're a little fair at the endpoints. But in the middle, you better do both sides, yeah. All right, so I keep saying both sides. I want to show you another example about what if they don't agree. But real quick, before I leave this guy, would you say it's continuous through x equals 0? Even though we haven't even talked about what the hell continuous means, what your gut tell you. No, you cannot travel from this side straight through. You go, oh shit, the road's out. Not only is the road out, but somebody threw it away over there. So you can't get there from here, right? It's like, well, I live on this side. That's my life, right? You can't get through, so it's not continuous. Here, is it continuous?
Yes.
Now, do you see why? Because the limit, what the function looks like it's approaching, is actually what it gets to. If that's true, it's continuous. You got a road that you can actually travel down the whole way. This is a new idea, but it really isn't an evil, hard idea. But certainly it's different from stuff you've seen before, yeah. And there's no filled in circle anywhere for it. What is... But there's a definition for what that value is. At 0, the function is a 2. Period. Does that look like where it was going to? No. It's a little magic trick, right? Is it a deck of cards? No, it's a rabbit. And you're like, holy shit, it looked like you were going into a deck of cards and you went to the rabbit. So this can happen, not only in functions, but this could be an estimate of what happens in real life. With some things that like instantaneously power up, or at least, on the scale of our perception. But anyway, that's what this would represent. Is this automatic ramping up of something. Okay, so what about this guy here? Let's see. Well, I like this one. This is pretty cool.